In this video, I'm going to discuss the data structures known as stacks and queues. So conceptually, these are similar to lists in that you are sort of adding and taking away items from the list dynamically rather than the array, which was not dynamic. Had a fixed size. These do not have a fixed size, but what differentiates them from lists is that you can sort of add. Well, when you add items, they add to like the what you would call, I guess, the top or the front of the line, and then are removed in that order. So a stack uh, is last in and first out. So conceptually, we see these dotted line things here are like our stack, and so we add an item, this number one item here, and then when we add another item, it sort of gets put on top of that, and then number three gets put on top of that. And then when you want to remove items from it, it sort of removes from the top. So three will get removed first, then you could remove two, and that would come out second, and then one would come out third. And so the last in is the first out. Then with the queue, it's first in, first out. So you know, queue in here in the United States, we usually use line. So you line up for something, or you queue for something. And so, if you are in line for something or in a queue for something, if you are in the front, then you'll be the first one. At the bank, say you're at the bank and there's a line. If you're in the front of the line, you'll be the next one to move up to the bank teller. And so with a queue here, it's the first one in is at the front of the line. Then the second one in is second, third, fourth, and fifth. And then so dequeuing. So when you sort of get called up to the bank teller, you come out of line first if you are in the front, and then if you're second, you come out of line second, and so on and so forth. And so those are sort of the main conceptual ideas for stacks and queues. So a stack is last in, first out, and so you kind of think about you put things on top and then take things off the top first. So, like say you have like a pile of laundry. If you start throwing things into that pile, the last thing you throw, which will be on top, is the first thing you'll pick back up when you go to pick that pile of laundry up. All right, so first I will discuss stacks. And so a stack, the syntax for that looks like this, where you do stack, and then in these angle brackets, you put the data type in it, and then the name of your stack, new stack, and then the data type in the angle brackets here. And this generates an empty stack, so it contains no elements. In fact, if you try to like remove an element, it will throw an exception to you. So the stack must be of a specified data type, and the specified data type has to be declared between the angle brackets. So like I said, no elements or size when nothing has been added, so the stack is empty. And so looking at this more explicitly for a few data types, we see we'd put integer in here. That would give us a stack for integers. We could do float. That'd give us a stack for float. Characters, strings, all the other data types we've talked about. And then we can also do these reference data types, so like classes, and I'm actually going to talk about that a bit more in the video following this one, actually, before I get into the data structures of dictionary, hash table, and linked list, because I think understanding this idea of reference data types and value data types will help with understanding dictionaries and linked lists and hash tables. All right, so like I said, the stack is dynamic. So adding elements increases the size of the stack, and removing elements decreases the size. So that's just like with the lists, except here what's different is sort of the way that you add and remove items. And so some of the stack methods that are important here. So if we have the stack name here, this method push, where you push an element of the data type that you declared for the stack, and so that adds an element to the top of the stack. Then pop, with the element here, removes the item from the top of the stack. Actually, these are mistakes which I will fix in the lecture notes that will be posted in the description. So pop and peek both do not actually take any arguments. So you would not actually have arguments in here. So that was a mistake here, which, like I said, I will fix in the lecture notes that you can look at and linked to in the description down below. But pop it, so it does remove an item from the top of the stack. Then peek is you retrieve the item from the top of the stack without removing it. So, for instance, if you do peek multiple times, it'll just keep giving you the same value because you are essentially just peeking at the top of the stack, that the item at the top of the stack over and over again. So this is just another sort of visual representation of that. So push keeps adding items to the top, and then pop keeps taking items off of the top. And so we can also use count, and so this gives us the number of elements contained in the stack. We have contains, and so this does take an argument here that determines whether the stack contains the element specified in the argument. And we have copy too, so this will copy the stack to an existing 1D array starting at array index specified by this integer here. So this does take the array as the first argument and this integer for the index as the second argument. And so before moving on to queues, let's take a look at some stack code here. So some code for stack. So I already have my classes all sort of started up here. And so we will start with the stack one up here. And so what I'm going to do is make a method for generating my stack. And so what I'm going to do is public, then I'm going to do stack. This will be our output or our return value right here. So we do stack like that, and then I'm going to do stack maker like that. So this is a method for making stacks. And so what I'm going to do is make a stack here. So int, so my stack, I'll call it my stack equals new stack int, so like that. Then I will do, so for int, we will do this up to 10 on here. So what I'm going to do is my stack dot push I like that. And so this will just make a stack where the first item will be 0, the second will be 1, the third will be 2, so on and so forth. So it will just make a stack of sort of numbers increasing in order. All right, so down here, so in my main method, I'm going to do stack demo stacks equals new stack demo. So I'm instantiating the object there. Then I'm going to do stack int my stack equals stacks dot stack maker. And so now I've made a stack here. Well, actually, I have to do return my stack. So I have to do that return on there so that it will actually output a stack. And by the way, I use the same name here in this method and down here, but it doesn't have to be the same name. I could name it something else down here, but I like to use the same name just to sort of show like what is sort of being carried over. So this method here is making a stack using this code up here, and it's outputting this. And so down here, I'm making this stack here using this method. So this stack will be made using this method right here. All right, so I'm going to do int s count equals my stack dot count, like that. And so that will give this s count here will be the number of elements in the stack. And so what I'm going to do is console.writeLine, and we will do stack count is like this. Then we will do s count like that. And so that will give us the number of elements in the stack. So if I run this, what we get is stack count 10. That makes sense because I'm filling it with 10 elements up here. And so that gives us the count for the stack. And so then what I'm going to do is console.writeLine from stack. So this will just give us all the elements of the stack. And so I'm going to do for int. We will do that. So up to s count. And then I will do this. So console dot write line, and then in here I will do my stack dot peak. Then I'm going to put some spaces in there, and so actually for this, instead of write line, I'm going to do write. And so something that's important here. So one of the reasons I did this s count rather than just going up to my stack dot count here is because if I did that, what will happen in this next line of code? So I'm going to do my stack dot pop, and so it's going to remove the top element of the stack. So if I just put my stack dot count here instead of sort of this concrete s count, that's not going to change. This my stack dot count is going to change at each iteration, and so it's going to go down by one each iteration. So as I goes up by one, the my stack dot count would go down by one. And so I would actually only iterate through half of the stack because the stack count will actually just go down by one each time. And so that would reduce the size of the stack at each iteration. And so this will give us the stack output that looks like this. And so we still have our stack count here, and then here is all the items in the stack. So what we're doing is we're taking a peek and we're writing that out in a line here and then putting this extra space between them and then removing the top element before iterating back over and outputting the next element here. And so we see this comes out in reverse order because it's last in, first out. So 9 was the last item we put in up here, and then that would be the first item that is printed out. And so then we can look at this method for putting a stack into an array. So my stack equals stacks dot stack maker. So I'm just remaking the stack because up here we removed all the elements from the stack, and so we have to remake it if we want to do things with it again. And so this will just remake the same stack because we're using the same stack maker method. So we'll do int, we'll make an array stack to array equals new int s count, like that. So we're making an array that has the same number of elements as our stack, here, and then we'll do my stack dot copy to, and so this just automatically fills that in like that. And so then we can do console.writeLine and from stack to array. So we'll put a space there. Then we will do for. So we will go up to, and this time what we actually want is we are going to go to the stack to array dot length. So the length of that array is what we're going to use there. And so then we will do console dot write line, so stack to array, and we will just print out all of those. So I'm going to put a space here and make this just console.write so that it all prints on the same line. And so then when I run this, we get this. And so I should actually put a space there. So this should be sort of right above this right here. But we see we've just copied it all over to the array, and it just prints out the elements like that, the same as from the array. And so what I can do just to make sure that these are on different lines. So write line, so like that. So now this will actually skip down to the next line when I print that again. But let's now move on and take a look at queues. So remember, the queue is the first in, first out. And so it's going to use this syntax right here. So queue data type in the angle brackets, the name of it, new queue data type in the angle brackets. So this generates an empty queue. So it contains no elements. It has to be of a specified data type, which is declared between the angle brackets. And it has no elements or size when nothing has yet been added. And so we can look at it this. So this is how it would look for integers and float, character, string, various other value data types. We can also use reference data types in it. And again, the queue is dynamic, so adding elements increases the size of the queue and removing elements decreases. And so these are the methods for it. And so instead of the sort of pop and push and things like that, we have NQ and DQ. We still have peak here, but now we have NQ and DQ. So NQ, we are adding an element of the specified data type. So here, this is correct. These do not take arguments here. So these are correct for the queues. So DQ, so it just removes an item from the front of the queue. In peak, so we retrieve the item from the front without removing it. Again, if you do it multiple times, it'll just give you the same value since it is not removed. I'll get into priority queue here in a little bit. So these are queue methods. So we can take a look at this. So we'll go up here, put in our queue methods. And so I'm going to make a method here. So public queue int, and I'll just call it queue maker. Oops, not supposed to have those extra right there. So we'll just call this queue maker, and we will then do this. So queue int my queue equals new queue int. Then we will essentially do the same thing we did for the stack up here. So for int, so we're going to have for this, so it's going to be I less than 10. So we're just going to make a 10 element queue here. So now we will do my queue.nqi, and so again we're just putting the numbers in ascending order. Then we'll do return my Q and then go down here. And so we will do, so I'm going to do Q demo, and I'll just call this Q's equal new Q demo. So we're instantiating the class there. So we're just going to do Q int, and we'll call it my Q equals Q's dot Q maker. And so again, we're just making this thing here that will output from this method up there. And so now we have this Q here, and so we can also do int Q count equals my Q.count. And so for the same reason as we did up here, we want to get this sort of set in stone, because as we iterate through, we're going to remove items from the queue. So we can do console.writeLine and Q count is, and we'll do that, and then we'll do Q count like that. And so here I'm actually going to do that. I think I had that. I was going to do that up here as well to put a space between those. Put the semicolon there. So now we have that. So we will do console.writeLine from Q like this. And so now we can iterate through that. So we'll do for int I. Here we'll do Q. We'll do I less than Q count. And then we will iterate through this right here. So we will just do console.write, and we will do my Q.peak, put that in there, and then we will do my Q.dq like that. And so what this essentially will do is show us the difference in how these are output. So when I run this, we get this. And so we see from the stack it comes out as 98765432110. For the Q, it's the opposite. It goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so as we sort of iterate through this, going through the stack, it comes out in reverse. Going through the queue, it comes out in the order that we put it in. And so that is just kind of a demonstration of, for the stack, the last in, first out, for the queue, first in and first out. And so now we can look at the another kind of queue, which is just called the priority queue. And so it's a queue, but each element is associated with a priority that determines its place in line. And so this this illustration here, so say we have this queue, it already has Lily and Marson in it. We add Mary here, and she actually gets put down here at the bottom, which is in this image here, the front of the line. So the priority, so the lower the number, so the lowest number is highest priority. So think as being like number one priority. So although for this 0 is even higher priority. So it's sort of that 0 index thing that you see all over in coding here in C#. So then if we add John here with 2, John ends up in the back of the line here. Then Sarah with 0. So she gets put in front of everybody who is a 1 or a 2, but behind Mary. And so the higher priority gets ahead of all lower priority elements, but behind elements of equal priority. And so again, this contains the NQ, DQ, and peak, but now we also have this NQ, DQ method here that takes an element as the input, and then you do int for the priority. So this adds an element to the queue with the specified priority while simultaneously removing the element at the front of the line, so the highest priority element. And so we can look at the code for this. So we can look at some code for this. And so I'm going to do a priority queue here. So I'm actually just going to put this in. I'm not going to sort of make you suffer through me typing all of this in. So I will just skip to the chase here for this. And so I end up with this. So this is just a priority queue maker here. And so we have this syntax here, the priority queue. So the string is the element, this int is the priority for it. And so I'm just making a priority queue with string and int, and then I'm just enqueuing all of these. And so we see these are just a bunch of words sort of out of order, but I've associated with each one of them a priority here. These numbers are the priority, and so that is the order in which they will come out of this priority queue. And so we can go down here, and I will put the code in here. And so again, I'm just going to sort of cut to the chase. And so what we see here, I'm just instantiating my class up here, this priority queue demo. I'm just making a priority queue with my PQ maker. I'm giving the count here, so using the count to iterate. And so what we see then, so from the string type priority queue original, so we have this right here. It's just going to iterate through this, and it's going to write this out in the priority order right here. So I'm actually going to comment that out real quick. So we can just look at this first part here. And so when I run this, what we see is that the words that come out of here are right here. So these are the words that I enqueued into it, but now they're coming out in the priority order, which gives them, well, it puts them in an order that makes a coherent sentence. So this is a priority queue example for the video. And so remember, we put these in this order right here. So it was the order priority this example for is queue video the A. And so when we ran it, it actually came out in the order based on the numbers here, these integers on here. And so that will make it come out in the order of the priority. So if I undo the commenting there, so we're going to remake the priority queue, and so we're going to do this NQ DQ here. So we're adding the word here with priority 1, and this will put here in and remove the this. So the word this, which had the priority 0 up here. So it's going to remove that because that's the highest priority, and so it's the first in the line there. And so then if I run this code, we end up with this. So this is from the priority queue here. This is a priority queue example for the video. Then from the string type priority queue, so we revised it. And so now it says here is a priority queue example for the video. And so we removed the word this and sort of replaced it with here with that code. But anyway, those are the stacks and methods, or the stacks and queues methods with also the priority queue. And the code, as usual, is here in the lecture notes, and with this one I have comments on all of it to kind of help guide you through what's going on. So if you want to look at the code in a little bit more detail on your own, you can check out the lecture notes linked to in the description down below. But anyway, I hope you found this video helpful, and I will see you in the next one.